Our next speaker is Mayia from physics, and the talk is entitled Making Memories with Magnetism, Using Magnetic Materials for Neural Computation. Let's give Mayia a hand.
In the last few years, artificial intelligence has taken the spotlight, promising to change the way that we interact with the world. But for all of its big promises, there's an important problem. While we have computer code that thinks like the brain, it's running on computers that don't. This means that talks to another, it strengthens their connection. But the computer parts we have now don't work very well for this. But in my field, we're finding that the solution to this problem could come from an unexpected place: magnets. But what do magnets have to do with the brain? To understand this, we need to know a bit more about how they work. Magnetism in materials comes from a property of the electron called spin. Electron spins have a magnetic field. So when all of the spins in a material are pointing in the same direction, their fields act, and you get a magnet. But spins in different materials can behave differently. In a metal like iron, they're like a bunch of first graders in a classroom, rowdy and pointing in every direction. But when you apply a magnetic field, it's like a teacher walks in and tells everyone to sit in their seats and face forward. They do eventually, but it takes a little while. And once the teacher leaves, they go back to being rowdy pretty quickly. But some materials are a bit more like sixth graders. They remember when they were too crazy before and the teacher gave them extra homework. So when the teacher walks in, they get in their seats pretty quickly. And when the teacher leaves, it takes them a while before they get up and move around again. This type of memory that spins in some materials have is exactly what we need to build a computer that thinks like the brain. We just need to figure out how to use it. And that's where my research comes in. In our lab, I see what happens when we stack different types of magnets on top of each other. By doing this, we can control the spins at their interface, causing them to form pathways and make connections the way that neurons do. In our lab, I grow the materials, which is what I'm doing here. I use different devices to measure their resistive and magnetic properties. And I take what I've made to X-ray facilities to really understand what's going on inside. Stand here, the closer we get to building a computer that thinks just like you. Thank you.
All right, thank you so much. You ready for some questions?
Yeah.
All right. So tell us about someone who's had an impact on your life.
I'd have to say my parents. My dad is also a physicist, and he would just always answer my questions when I was growing up and sort of brought the enthusiasm that I have for science now. And my mom would always be supportive of the weird career path I chose, and tell me to take a break and calm down, which I really needed. Yeah, they're watching on the live stream now, I think. So hi, Mom, hi, Dad.
I love that. What is your favorite way to recharge?
Yeah, I have a lot of hobbies. So I like to paint, I bake, I crochet. UCSD also has a craft center, and I started doing ceramics. So that's been a lot of fun. Yeah.
What do you make? Ceramics?
It's like wheel spinning. So you make pots or like mugs. Yeah, it's just playing in the mud, basically. Yeah, it's fun.
Really fun. Okay, let's talk about campus traditions. So if you could create a new campus tradition, what would be your idea?
I was thinking about this, and I feel like a beach cleanup day would be really cool. Something that helps the community and everyone's out at the beach. So it would just be a fun day, and maybe something with scripts so we can help the local environment.
Would you bring some magnets out to help with the cleanup?
If it would help.
All right. Finally, what is your favorite thing about San Diego?
I love everything here. I'd But the people are just great, and the weather, the whole environment.
Well, we're so happy that you were in stars too.
Yeah.
That's awesome.
Thank
All right.
you.
Well, let's give her a hand. Thank you.